Okay, so it's 11 o'clock. I'm going to go ahead and get started. It's 11 o'clock Pacific time. This is February 21st, 2016, and I have Eric Dollard on the call. Eric, can you hear me okay?
Yeah.
Okay, we might as well go ahead and get started here. Let's see here. Back in early December, I went down to Eric's lab and spent a few days there and filmed quite a bit of stuff. We went out to the seismic lines and did a little tour around the shop so everybody can kind of see all the equipment that's been accumulating. And also talked a little bit about Lone Pine Writings and did an interview with Steve McGreevy. We did a little shoot of Eric doing the network experiment on the bench. And I think the only little video segment I have left to put up on YouTube, which I'll do here in the near future, is Eric was talking about some old tubes in a old reference book, and we'll just put a description in the YouTube video what that's about. But that's kind of a little short, couple-minute segment. Also, let's see. Eric is going to be speaking at the 2016 Energy Science and Technology Conference in Hayden, Idaho. That's going to be in July 8, 9, and 10. And the website for that is energyscienceconference.com. We limit that to about 150 people, and there's already only about maybe 40, maybe 41, 42 seats left. But that is 4.5 months away, so there's plenty of time to send in payments and everything, and we'll cover a little bit about what Eric's presentation is going to be about. About 2 weeks ago, we released notebooks 4 and 5 out of a 5-part series. Actually, Eric is already on notebook number 8. So, Eric, do you want to take a minute and kind of explain actually, before going into the books, do you want to talk about what your presentation at the conference is going to be about?
Basically, the presentation is going to be a continuation of the extraluminal presentation.
Okay, and that's the talk you gave, I think, in 2014?
Yeah, the year before last.
Okay, so in 2014, the presentation was Extraluminal Transmission Systems of Tesla and Alexanderson. And do you want to explain, maybe take about a minute to explain what that presentation was about and what you're leading into with the next presentation?
Yeah, that presentation was kind of a layman-orientated pictorial presentation to lay the groundwork of the history and the basic terminology, how this factor of the speed of light came to be and how it entered all of the equations and led to relativity. And then there was a quick run-through of the Tesla Colorado Springs and the Bolinas Alexanderson antenna and some more practical type of transmission structures like the Los Angeles Department of Water and Power transmission line and then transformer resonances. None of it was in any detail or allowed for any calculation. This time around, it's not going to be layman-orientated. It's going to be more engineering-orientated, and the mathematics is going to be fully developed with the emphasis on what's called the equivalent network of these devices, or what are known as analog computers, and the theory and the development of the concept of the analog computer, and then its application primarily to the Bolinas Alexanderson antenna, and then, if there's enough time, to the Colorado Springs. And there'll be numerous practical examples in the beginning that lead up to it, such as a common electric railway line and then a phone line running between two towns. And so familiarity can be gained, and the emphasis again will be showing that the velocity of light really is a numerical and dimensional coefficient. It really doesn't have a lot to do with the speed of transmission, or there might not even be a speed at all.
Okay. And so, so that'll be the presentation at the conference. And then what is the title of the presentation going to be?
Oh, that's still being hashed out. I think I gave you a...
okay. Yeah, electrical
kind of
transmission. Yeah, electrical transmission in multiple coordinate systems.
Right.
Okay, and there is a description. It'll be one or two short paragraphs, which I'll be putting up on the conference website. And let's see. Now on notebooks 1 through 5, recently we released notebooks 4 and 5, which you refer to as the J.J. Thomson and Steinmetz notebooks. But there's also notebooks 1 through 3 that come before that. We decided to put out notebooks 4 and 5 first because after your presentation at last year's conference, The Power of Ether as Related to Music and Electricity, that ended with you going into some of these equations and straightening out some of the mathematical stuff that was in the back, that was in some of J.J. Thomson's work. And there was such a huge response with people being interested in more on J.J. Thomson that's kind of why we released these first. Do you want to give a little synopsis of what notebooks 4 and 5 are, the ones that we just released about 2 weeks ago?
Well, the whole series of notebooks, including the ones that I'm writing now, are based on the extraluminal presentation and the upcoming presentation. Notebook number 4 is the untangling and deciphering of the chapter on the Faraday tubes in J.J. Thomson's book, Recent Researches in Electricity and Magnetism. And I don't think anyone has ever untangled them before. And the emphasis was to show how resistance comes about inside of a metallic so-called inductor and define its dimensions so that in later notebooks it will be known exactly what resistance is. The notebook prior to that, notebook number 3, develops inductance and capacitance, and then notebooks 1 and 2 are basically the prior presentation verbatim, just written down for the more layman-orientated type of situation. Then notebook number 5 is a result of a paper I spent. Yeah.
Okay, it sounded like there was a little bit of interference on the line. Okay, it seems like it kind of cleared up now. Okay. Okay, go ahead.
Somebody's transmitting. So, yeah, notebook number 5 is based on a somewhat obscure paper by Steinmetz that allows you to accurately calculate the forces on the conductors in the transmission system from the magnetic standpoint and utilize it.
Eric?
Yeah.
Yes, it sounds like when you start talking that there's like some vibration noise that's coming over your phone that starts to get louder.
Well, it's not the phone.
The cord
it's something in between.
Okay, that sounds okay right now.
Yeah.
Okay, go ahead. Sorry, I just wanted to kind of get this chance to.
Yeah, so basically, I've been struggling with trying to come up with these equations on the force of my own because the material that's in physics books is completely useless. And that's putting it mildly. So you can't get anything out of a physics book that will even allow you to perform the most rudimentary electrical calculations. The stuff is just pure garbage. So Steinmetz wrote this paper showing how the forces really come about. And then in his book, Impulses, Waves, and Discharges, he shows you how to make the transformation from magnetic to dielectric. So I was able to calculate the dielectric forces as well as the magnetic forces and show the relationship between the two, and then put the whole thing in a basic algebraic form that finally leads to a Heaviside equation for the forces themselves. And it allows you to actually calculate how much force is on the conductors in a transmission system during a short circuit or some kind of condition where there's a lot of current flow, and it's actually pushing the conductors hard enough to make them fly off the insulators or to make the windings fly apart inside a transformer. So then in Notebook 6, which is not out yet, all of this stuff is reduced to the level of the Lone Pine writings, which is basic algebra, and then the dense theory part is over, and then it goes back to a very practical situation of commonplace electrical power lines and actually calculating the fault current and the forces upon the wires and the voltage drop and the energy lost and all those kind of things leading up to the generalized transmission concept, which will appear in Notebook number 8. And then Notebooks 9 and 10 will probably bring this into the actual calculation of Tesla transformers and Alexanderson antennas. We'll have to see how it goes. So, because I'm being very methodical about laying a groundwork for everything, and that takes about 100 pages for each basic idea. So this is probably going to be about a 1,500-page collection of notebooks.
Okay. We can probably see if anybody has any questions on notebooks 4 and 5 that were recently released. Before we do that, are there any things that you want to cover first before we go into that?
Not really, not yet anyway.
Okay. Well, what we'll do is, if you're listening to this call right now, everybody is pretty much muted out. But if you have a question on these recent notebooks that were released, the Thompson and Steinmetz notebooks, which were available on powerofether.com, you can hit 5 and the asterisk, and that'll give me a little symbol next to your phone number, and I'll call out your last 4 digits of your phone number, and you can hit 4 asterisk, and that will unmute you, and then you can ask your question. So does anybody have any questions on those notebooks? Just hit 5 and the asterisk. It doesn't look like anybody has any questions. Okay, well, we can just open up for general questions if anybody has anything that they want to ask. I know in the Facebook group there's quite a few people saying that they wanted to have a Q&A call because there were so many different random questions. There was no way to address them, one at a time on there. So let's see. Okay, if your phone number is ending in 4394, I believe I just unmuted you. You can go ahead and introduce yourself and ask your question.
Hi, my name is Mel Messer, and I'm wondering how Eric is doing on his seismic sensitivities project.
Okay. Am I online, Aaron?
Yeah, you are. Did you hear the question?
Yeah, I came in clear.
Yeah. Oh, okay.
So everything's basically on standby right now because of weather and catastrophes. We haven't made much progress on the line, so we're planning on resuming the situation in April 1st. We have pretty much all the equipment. The complication is we don't have the money to build the terminal building for the seismic graphs and their amplifiers and modulators and what have you. That's a big hang-up. So it looks like the situation is going to rest in that we can have the telluric antenna structures complete. The one to the east of the test site, we expect to have operational probably in mid-May, but then we have to lease a space from the whatever you want to call the group, the syndicate that has all the Sillyphone facilities, and then put the terminal equipment in the building. We have no money for that lease right now. We're barely able to pay for the building we got. So it's not really moving ahead very fast. But at any rate, last year, me going blind threw a monkey wrench in the situation. That has backed off. One eye is fairly useless, but one still works fairly well. Then when we began this year, the snowstorm started, and then the sewer system failed to the building, and the head gasket blew in the truck, so we got nowhere. And then everybody that provided money for the situation called us cat turds for not finishing by the end of the year, and it seems that they expected the whole Landers facility was going to be reconstructed, which is not realistic. So nothing is moving ahead very fast, but by the end of this year, both the east and the west transmission structures are expected to be finished. Now, the west one is more of a scientific type of structure where it's adaptable and that you can sectionalize it, and there's networks that can be attached, and there's test lines for measuring phase velocity and all the characteristics of the structure, where the The west one is basically a simple structure just to start receiving without a lot of complexities and experiments, and just get the thing up and running with basically just 2 ground systems on either end of a long transmission line. That's the easiest way to start. And so that's what we're going to emphasize our effort on first, is to get something that's receiving and ready to be hooked to a terminal facility, in this case a large microwave site, so that when the money comes to lease a space in there and get a link, then the Earth signal receiver should be available through the internet, or however, what kind of broadcast mediums are available this day and age, where people can dial into the thing and listen to what's going on in the Earth in the Mojave Desert.
Well, that would be great.
Now, which one is east and which one is west? Which one is near your shop?
That is the west one.
Okay, that's the west one. So the east one is the one which is a couple hundred miles from there.
Yeah, it's about 250 miles away driving. So as the crow flies, it's probably maybe 180 or 200. So that's the optimum distance for stereo reception. Here we might have a problem with power line interference because the utility company, internationalist utility company that's taken over all the electrical lines in Nevada, seems hell-bent on creating a giant jamming device out of their electrical grid and is quite obstinate about it. So we're afraid that the structure here might only be useful for mathematical study purposes and will not be good for reception. So we can't really get these things out where we want them because of for one thing, to put up 40 or 50 utility poles is beyond anything we can afford or do between the two of us. So we have to use structures that are already available, that are provided by the Bureau of Land Management, usually abandoned telephone company or cable TV, or military facilities that we can reconfigure. But they're not necessarily in interference-free zones. We do have an easement near San Francisco where we can put some kind of structure up in a completely interference-free zone, but this is not a good time to open up a third avenue in this or just get ourselves overextended. I would like to point out that most of the external money that comes in, not really a lot of it goes directly in the project. Most of it has to go into supporting the building. And the public, what do you call it, the crowdfunding or whatever, that money, all of that pretty much went into buying the necessary hardware. And then we received a massive donation of equipment from a group that called themselves the Eric Dollard Fan Club that not only has allowed us to build the terminal equipment for the lines, but to set up a rather significant Navy electronics technician shop here in the building, but we don't have any money to put in the benches or the electricity or all that kind of stuff. And most of these kind of things, including, the gas for the antenna work, the food, the small parts and the expenses and car repairs, all of that comes out of my Social Security and one matching fund donor. So as Josh Reynolds said when he cut off everybody that he'd been funding for quite some time, is that Eric Dollard has done more on welfare than you have with my millions.
So do you have more questions about the seismic project?
I drank some water.
Okay.
Sir, did you have any more questions about the seismic project?
No, but thank you for asking. I'll contact you on Facebook.
Okay, thank you.
Yeah.
Hey, Eric, is there anything you might be able to mention about other applications of the transmission lines once everything is up and running besides seismic forecasting?
The main emphasis of the project is the continuation of what I was doing at RCA Bolinas, which is developing a ship-to-shore communication system.
Uh-huh.
So that's initially what RCA had set me on in 1974. And neither the district vice president nor myself knew anything about Tesla back then. I had discovered a lot of what Tesla was doing on my own in the laboratory that was provided to me, or the equipment was provided to me to build the laboratory in my parents' garage. So RCA was on its last legs, radio was becoming obsolete, and the satellites were taking over, so my job was to figure out some way to come up with a new ship-to-shore communication system to revitalize the business, but that took about 20 years to figure out, and then by the time I figured it out, they took the station license away and destroyed everything there, so, and then let Greenpeace have whatever remained, so now it's starting all over again.
Okay. Let's see. If your phone number ends in 9151, I'm going to unmute you right now. If you want to go ahead and introduce yourself and ask your questions. If your number ends in 9151, you should be unmuted if you want to go ahead and ask your question. Let's see, if you have your phone muted, shouldn't be muted, but in case it is, you can try 4*. Okay, it looks like you're unmuted to me if you want to go ahead and ask your question.
Hello, can you hear me?
Yes.
Sorry, had a little trouble with the phone. Yeah, Eric, I've been watching with great interest lectures that are available on YouTube recently. I have a friend that has built all kinds of free energy devices and inventions. His whole house is a lab, basically. We've been just very interested in what you've been doing, but I am a little bit new to it. So I have 2 questions. First, there are 2 lectures available online on YouTube: the origin of energy synthesis, and then one other one that covers a lot of history. And is there any others that have been published or could be republished, or are they all being tied up by the Tesla group?
The San Francisco Tesla Society has still held one back. That what I did get had to be gotten very covertly and what have you. They really wanted to sit on all this stuff. So what's out is out, and there was one final one on the Alexanderson system and the Bolinas transmitting site that didn't make it.
I see. Okay. My other question had to do with some material from the origin of energy synthesis. You gave a fantastic description there of lines of force and how you need to visualize ether and dielectric and magnetic flows. We found that very useful, especially the equations you included with that. And a thought occurred to me that, since I'm kind of a very visual person, I've seen some people try to use a CAD program to diagram some of the electrical forces and various motors and things like that. It makes it very easy to understand. I was wondering if there was any possibility maybe someone in your network or that you work with might be able to do something similar with some of this information so that it's a little bit more clear. I had watched how you had diagrammed the 4 different poles and then later expanded it to 8 poles and talked about the math and how these things play out in a coordinate system. And it just occurred to me that if it was possible to graph these things within a full coordinate system and just watch the points dance around, might be able to find some relationships that work out. In particular, if you had a weighted point for each of the 8 operators, it might be interesting to see if any of those points maintained any constant or predictable distances relative to each other over the course of a cycle. It might produce something akin to the cymatics experiments of magnetic fluid when current is passed through them, where they create platonic solids, things of that nature. I just thought that would provide like a visual 3D representation of some of the resonant frequencies being created over the course of a cycle. And I just want to know if you had given that any thought, or if anybody that tried to do that you were aware of.
Well, yeah, that would be lovely if there was a field mapping situation, because to do it, but with regular mathematics, the labor is just insane. But no one, well, you have to remember basically that I'm a feral human and I don't really have contact with the human race. So there's not really a lot of people around that I can engage with in this stuff. The few that I have turned out to be useless or worse. So basically it's just me and Justin, and, on the mechanical level of things. That's something that would be important to do a field mapping of a lot of this stuff to see, how the longitudinal and transverse elements play out. But it's just simply there's nobody there to do it. I don't.
Well, it's not a skill that I have, but I was hoping maybe bringing it up on this call, someone might take an interest and sort of volunteer their expertise in trying to do that with your equations. So I guess I'll just leave it there and hope somebody can pick up on this and definitely publish on YouTube so we can see.
Yeah, well, the equations for the field mapping itself would have to be developed to begin with, which is a big project. So the best I can do is to deal with it with the regular methods of wave analysis, traveling waves and standing waves, and the end results, to bring it to a level of potential and current rather than flux densities and directions. And even that is a mathematical nightmare. I mean, just a simple pair of wires on glass insulators handling a telephone call is the general solution to that transmission line has never been completed. It's beyond human comprehension, not alone dealing with the network of conductors and the configuration of a Tesla transformer or motor windings or all that to figure out what kind of wave propagation is going between. I'd have to have somebody that, is a PhD mathematician to assist me with that. Am I still online?
Yeah, well, thank you for your answer.
Okay.
Okay, thank you. Okay, let's see if your phone number ends in 8441. I'm unmuting you right now. You can go ahead and introduce yourself and ask your question.
Thank you, Aaron. Francis from Nebraska. 3 questions, really, if I can. I'm sure all the listeners out there would want to be praying for your eye. Eric, did you poke it by a branch out there in the woods? Is it cataracts, glaucoma, what? Secondly, Aaron, I tried your website that you just mentioned. Maybe you could tell me the poweroftheether.com, AETHER, and I just get server not found. And then the last question, if you could.
Okay.
Go ahead.
No THE in front of it. Just it starts with powerofether.com, 3 words.
Oh, thank you. Okay. So the I question, and then the last one is, Eric, I wish you weren't working on ship-to-shore stuff. We don't have any ships in our network that I know of, but we care about our cell phones. All of us patriots and free energy inventors and people that follow you and there and goes on there in Idaho. We want to get rid of the government snooping in on our cell phones. I wish you could invent some kind of a secure, Earth wave-based communication device that I could buy a cell phone from you and it would, talk to some base in Idaho, and then from there it would go out over the cell phone network to talk to my grandma in, Arizona or whatever over her cell phone line, because obviously everybody in the world is not going to convert to your ground wave system immediately. But is that possible? We could pay you for that?
It's not really feasible because there would be so many FCC allocations, and the bandwidth gluttonry has basically made it impossible to use pretty much any of the conventional communication systems anymore because people just want too damn much bandwidth. So my situation, I don't have a cell phone. Right now I'm talking to you on a Western Electric Model 2500 electric technology, not electronic technology telephone. It cannot be controlled externally. It does not talk to people behind my back. When I hang it up, it's disconnected. And the thing is, if one does not want to suffer from the negative elements of Babylon, the thing is you have to not participate in it.
Okay, that's all. I have lots of other questions, but I'll let other callers jump in here. Mine are all pretty esoteric and stuff, and maybe in the end I'll get some more in. Thank you very much.
Okay.
Well, if you want to go ahead and, nobody else has their hand raised right now. If you want to go ahead and ask a couple of those questions, go for it.
Oh, super. Let's see. You were working on was it a CIG, some kind of a spiral-bound thing that you two wouldn't just face each other, and what all was that capable of, other than just putting a tube in between and seeing a galaxy spin, inside of that vacuum tube or whatever? Was there what other fantastic things could that invention do, or what was that capable of? Thanks.
Well, it wasn't really an invention. What it was is basically two Tesla transformers pointed at each other, running in push-pull. It was basically a continuation of Nikola Tesla's vacuum tube research and some of Philo Farnsworth's vacuum tube research. And the galaxy was the specific aim of the experiment. Otherwise, when the two coils are separated, or more properly, the two transformers are separated, they communicate to each other tellurically, and then that allows for basically a communications link, point-to-point communications link.
Okay. Did you have any other questions? Okay. Can you still hear me, Eric?
Yeah, I can hear you. Sounds like his line got disconnected or something.
Okay. Well, I'll go ahead and mute him out, and if he has another question, he can ask that when we open up here in a bit. Let's see.
Hey, Aaron, I am Mario.
Yeah, Mario, you have a question for Eric?
Yes, Mr. Eric, what will be a functional thinking explanation concerning the ball lightning phenomenon storms?
Oh, I'm not quite certain. I can't quite understand what you're saying. Did you get the question, Aaron?
Yeah, were you asking what is Eric's perspective on ball lightning?
Yes, exactly.
Okay.
Well,
did you hear that, Eric?
Yeah, I mean, I haven't really had an opportunity to. What I made in the bulb was one thing, but how ball lightning comes about or whatever in nature, it doesn't happen often enough to really study. But I did find out recently from Steve McGreevy that there's a place where these type of luminations occur on a regular basis in Texas. I forgot exactly what the location is. And somebody went there with one of his electrostatic receiving devices, and it was found that a lot of these earth signals that we get on our equipment are actually originating from these telluric generated ball lightning type luminations, which was kind of a fantastic revelation for me, because it's generally believed that these signals come from something called the Earth ionosphere waveguide, which, as Tesla pointed out, doesn't really exist, not in the way that it's being represented. It's a fabrication. And my research at Landers showed me that most of these signals are originating from inside the Earth rather than outside the Earth. So it's quite possible the ball lightning is some kind of focal region between an external electric field exterior to the Earth and a telluric electric field interior to the Earth, and it's a convergence point where then you get the illumination. But that's a theory, but it seems that it's plausible. I would say that's a good possibility of how it's coming about. So it's very similar to the convergence or the cosmic superimposition that occurs in the two Tesla dielectric fields, where you get the galaxies and the balls and the planets and the suns and all the cosmic formations in the middle. Seems to be a similar type of process. It's interesting that Walter Russell actually drew a series of diagrams that this whole process in a book he wrote. I got it on the shelf here somewhere. This Secrets of Lights or some situation. I forgot the title, but as esoteric and as far out there as a lot of his diagrams seem, some of them are very interesting portrayals of the actions of forces in nature that are not acknowledged by establishment science.
Thank you, Eric.
Okay, thanks, Mario. Let's see, if your phone number ends in 9771, I'm unmuting you right now if you want to go ahead and introduce yourself and ask your question.
Hey, my name's Michael Leese. I'm fascinated with the work that's out there and I'm really glad you guys have pulled together like this forum and stuff and just watching it unfold. I've got this little project called the Magnavox Research Project, and I'm into Tesla coils and stuff like that. And part of it, I got a couple questions here. One is on the etheric field. And I was always wondering, I think it was mentioned, it might have been John Bedini had mentioned something about Tesla coils, and that when you actually activate a Tesla coil, you're not really putting power into the system, but you're actually drawing from the etheric field. And I was just wondering if, like the high impulse, sudden impulses of things, what it actually does, it creates a greater variance of energy pressure in that etheric field so that one can actually tap upon that wavelength. You're not really creating anything or putting anything into the system, but you're just moving that field around so that you can either charge or discharge according to your resonant attunement to things, or, like an antenna, so you're actually pushing out a wavelength, and on the other end, you're actually picking up that wavelength. So I was just wondering if according to how you're pulsing that Tesla coil, you're just basically activating the etheric field that's already there, and then on the other end of that receiving system, that you're just getting the flow of that energy back to your system.
Yeah, I'm not quite certain what you mean by the etheric field, or I haven't experienced any of the devices tapping into any energy. The only working example of that I know of is the Tesla Colorado Springs unit that managed to somehow communicate with the electrical system of the Earth, and then the electrical activity of the transformers became much more intense than could be accounted for by the electricity supplied by the power transformer. So now it's hard to say if that was an accumulated energy, like a resonance over a period of time where the magnification factor of the Earth played an important part, and then the energy that he put in came back later. But from what the switchboard operator described, J.J. O'Neill book, it appears to me that Tesla actually tapped into some kind of how would you say, energy field, or the flow of the interplanetary flow of electricity that normally you can't access.
That makes sense, and the only reason why I'm saying that is because
basically he placed a section of transmission line in between the cosmic transmission line, and then once he tuned in, then his system engendered the cosmic power flow until it finally, the RF burned out the generating station running his facility, and then there's nothing more said about that by Tesla or any of his assistants afterwards.
Okay. That makes sense, because I was always looking at, you brought up Walter Russell and this whole idea of, the array that he has and the spirals, and I was wondering if there was a means and method, or if anybody has ever tried, this whole design of the Fibonacci sequence and the golden means, if electricity was pulsed in a certain ratio to where you get a regenerative effect. And that's what I was kind of seeing, if Tesla coils, if they were pulsed on sudden impulse. Now, I was reading into some of Tesla's patents, and he wasn't just putting out a high-frequency, high-voltage, but he was actually pulsing that high-frequency, high-voltage, which gave him a high-frequency, high-voltage impact pulse into the system. And was there any difference if it was done in a certain sequential manner to where that would create a regenerative effect where you have a crescendo in the wavelength of energy that goes out.
Well, yeah, if you tap in, if you mutually have a mutual admittance to a larger system, like the cosmic system. Now, one thing that I did notice and duplicated Tesla's work in this area is when the bulbs are within the cosmic induction field, even though there's a very low pressure inside the bulbs, residual argon gas, basically to stop the filament from evaporating, and the force upon the glass, because of the partial vacuum, is from outwards in. So if you heated up the glass on the bulb, it would cave in. In a normal situation, this is what happens when a bulb is lit with conventional electricity. But in this case, even though there's this partial vacuum in the bulb, an ether pressure started to build up in the bulb, such magnitude that the bulbs actually physically exploded. Once the cosmic formations began inside the bulb, you could hear the pulse repetition frequency hammering on the glass of the bulb. And usually, right when you got the visuals, you had to cringe, because within 5 or 10 seconds afterwards, there would be a violent explosion of the lamp under pressure. And if the dielectric losses of the glass caused it to start to melt, the glass actually bulged out rather than was pushed in. And Tesla indicates this in his writings with the vacuum tubes, that he was getting this effect is once you create this situation, you have caused the ether to exhibit a physical pressure upon matter, which is a rather outstanding result or observation.
So really, in a lot of the people doing Tesla coils where they're throwing the huge sparks, they're not really getting the same pressure wave.
No, those things are just jerk off. So you don't put
because you really want the pressure wave.
Have lightning bolts jumping all over the place. If the thing's making sparks, it's not doing anything. It's shorting itself out.
Makes sense.
The thing is, it's the length to width ratios on those coils are optimized for generating sparks and are completely disproportionate for getting the proper electrical fields to do this type of research. So
that's cool, because that's kind of what I've been seeing in my own thing, because I've taken a hairline, it's got to be a 36-gauge wire, 50-foot, 36, and I put it up on like a little telephone pole that I've made, and I can take my sender, which doesn't have any sparks jumping off it, and instead of going to ground, which normally would, take that wire from there, run it to a receiver coil on 50 foot out with that 36-gauge wire, and from there I can turn it on and light a 110-watt light bulb, and then have that almost like a repeater at that far end, take another coil and then turn on a motor, because it's just the high frequency almost creates like a static field around the coil.
You don't have frequency anymore. You're using what's called impulse current transmission. I think you wrote me a letter on that, didn't you?
I might have sent some on email stuff, but I've never really made contact. It's like my first time. I'd love to do things, but it'd be, I'm totally impressed. I think you're the only one that's out there who's really starting to see the reality of what's going on. I mean, it's completely opposite of what the normal people are saying. There's a friend of mine who's just graduated in physics, and it's like, man, I just can't agree with what you're trying to tell me. But I just wanted to throw that out there. But I really appreciate, the contacts and just seeing what's going on. I think it's kind of waking up some people on some new ideas. So it's cool. So that's about it. But thanks. Hey, it makes sense.
So yeah, what you're talking about is impulse current transmission. It's a frequency. It's an imaginary frequency in decibels per second, not cycles per second. And there's a very abrupt transition. And it seems like Tesla did numerous experiments in this area with the one-wire transmission. And the type of transmission involved along the one wire is neither conduction nor is it conventional electric field wave propagation. It's some other type of very obscure electrical wave that all knowledge has been forgotten It's called the surface wave. A German theoretician by the name of Sommerfeld wrote some papers on this, referred to in the second volume of Ernst Gilliman's Communications Networks in the introduction, that there's all these other waves, and if you're using sinusoidal waveforms, you can't get this effect except at an extremely minimal level. But if you're using disruptive impulse currents, it seems that it's exciting some other propagation along the wire. And when Tesla took a dive at Wardenclyffe, and there was this massive flood of electrical experimentation that followed until finally Franklin Delano Roosevelt, when he was Assistant Secretary of the Navy, outlawed and put a stop to the whole thing. But in that period between around 1904 and 1912 to 1913, everybody under the sun was experimenting with all this stuff and trying to modify Tesla's patents and whatever. And there was one very prominent researcher that came up with the best working systems, the only one that the Navy found would be workable for ship-to-ship communications. That guy was named Reginald Fessenden, and he used a surface wave type of propagation. It was not electromagnetic. There was another prominent electrical experimenter. I don't know his first name. His last name was Massey, and he had concocted a way to transmit along the existing magnetic lines of force of the Earth's magnetic field and use them as conductors for broadcasting purposes. So there is a whole plethora of electrical waves out there that are completely forgotten, and the physicists are the high priests of denial that say that all there is electromagnetism and there's nothing else, and then they can't define electromagnetism.
Makes sense. Yeah, because I believe there's a sea of energy, and we've just barely begun to see, the variance of frequencies or whatever we want to call it. That's why I was wondering if that etheric field, if there was a means and method through Tesla coils, because you can get any, depending on the size of the coil, the wire size, and the impulse that you apply to it through your capacitors or your tank circuit, you can get a variable of frequencies that are just infinite on the spectrum, depending on how you build your system. So somewhere in there, I believe there's a natural patterning. Supposedly they say like a love frequency is 528, and plants and things stimulate, and even the human system fluctuates on it. We're driving everything in our systems at 60 cycles, which is a very low frequency, so to say. I was figuring that Tesla was trying to work his stuff in millions of cycles, as he stated in one of his patents on designing of transformers, that you can actually reach the speed of light by the multiple of, the quarter of that wavelength. So if you build your system and tap that 1/4 of that speed of light wavelength, that you're actually somewhat in harmonic resonance. It's like playing a low C note on a piano to reaching the high C note on the piano. If you tap the low C note, you're somewhat harmonically reaching that high C note. So it was always the thing in my mind of saying, okay, if nature is replicating itself on some Fibonacci design, self-replicating it from seed to flower to seed again, then electricity and magnetism in and of itself should self-replicate itself along regenerative lines if the system's built in proper sequence to match those designs of nature. So it was just thought, but I totally appreciate what you guys are doing. So.
Thank you.
Okay, I got to run to the bathroom really quick. I'll be right back.
Okay. Okay, if your number ends in 3810, I'm going to unmute you here in just a second when Eric gets back. And you can ask your question. And and if you're joining, have recently joined our call here, we have Eric Dollard on the line. And
okay, I'm back.
Back. Okay. So
yeah. So at any rate, with that last call, I would advise to be careful in a situation, because you might tap into something and get out of control, and then all of a sudden you end up with a nuclear blast. So my theory about how a nuclear explosion works, it has nothing to do with E equals mc squared whatsoever, but that somehow it triggers a disruptive dielectric discharge of the dielectric field of the Earth, and then all that induction comes thundering into the central point and produces the massive impulse of energy. And I don't think that's something you want to have happen on your workbench.
Okay, let's see. We'll go ahead and open up for another question. If your number is ending in 3810, you're unmuted if you want to go ahead and introduce yourself and ask your question.
Yeah, hi. My name is Alex Johnson, and I am an engineering student out of Colorado. And I am currently attempting to build a Tesla-style induction coil, the one which was wound separately in two parts. Are you familiar with what I'm referring to?
I don't exactly know what you mean, but I'm familiar with all the coils that Tesla made.
Yeah, I'll be a little more specific. It was referred to in his London lecture. It was a coil which was wound oppositely in two parts. The primary was wound on the inside of the secondary. And basically, he said he ran the circuit with a hairpin-like disruptive discharge spark gap interrupter. And I tried to replicate that coil, and I am having a little difficulty with the interrupter. And after looking over some of your work, I was wondering if you had any suggestions with the spark gap interrupter, or with what interrupter would be better to use with this Tesla coil and other Tesla coils like the Crystal Radio Initiative.
Well, that's the biggest complication in duplicating Tesla's work, because to date nobody has been able to duplicate his high-speed mercury switch. That's just simply beyond the capability of most experimenters. So the Marconi and the other people used what's called the rotary spark gap, where you have a disk with terminals on it, and then those terminals pass between the points of a spark gap and close the circuit. That's about the best that's available. Otherwise, I came up with a method using hydrogen thyrotrons and radar pulse transformers, but I think that stuff is very hard to find anymore, and I've lost all of it in the looting of past laboratories. I have no more equipment, nor do I have enough lifespan to really pick up on that avenue of research, but hydrogen thyrotron is the best way to go about it. You really don't want any spark at all. That's the thing. You want to switch. So, but in some situations, that might not be desirable, and you might just want to use alternating current, like in the Crystal Radio Initiative, where you're trying to do AM radio broadcasts. But then those same coils will produce interesting results with the disruptive discharge. So the rotary gap is probably about the best that's available. I would, research that and look at the various ones that Marconi and other people used and how they got the best rotating speeds and dwells and all that type of stuff. Otherwise, some kind of powerful mercury-wetted relays, but none of those things are really made for the voltage. So the device that Tesla refers to as the circuit controller, or what would be called the interrupter, or the brake was another name for it. That is one of the most difficult parts of the Tesla system to reproduce.
Okay, thank you very much. And do you have any opinion on Litz wire used in the Crystal Radio Initiative coils? I read online that those were better for crystal radios. Yeah, Litz wire is, providing that it has the right dimensions, is good up to about maybe 2 or 3 megacycles, and then beyond that, usually a hollow conductor, where the metal is made thin so that it can take part in the process instead of being thick where the electricity can't get to the center. That's usually the way that I prefer, because the stuff's more readily available. I got some very large rolls of Litz wire here. If I can ever
ever get to the point where I'm building the Tesla transformers for these AM transmitters I have sitting here. But that stuff's not easy to find, large gauge Litz wire. So it's not really for the Crystal Radio Initiative. I think if you just use the silver-plated coax, which serves as a piece of tubing, I think that's probably adequate for what's going on. Because to try to find 10 gauge or 8 gauge Litz wire might turn out to be very difficult. And then the Litz wire strap for the primary, I don't know if anybody can find that. Now there is a cable that was once available when the Bell telephone system was still intact. It's called Key Telephone System Cable, or KTS cable. And it's basically conventional telephone cable, but in a more flexible jacket and without the shield and all that. And all the pairs are specially interweaved to minimize crosstalk. And if you take a 25-pair KTS cable and you hook all the wires in parallel and make it just one conductor, that is a very effective form of Litz wire for forming the primaries of the Tesla transformers up to 3 megacycles. Beyond that, copper tubing will work just as good.
Okay, thank you very much. And one last question. I'm sorry. I just was wondering if someone wanted to help you in building coils or just generally help around the lab, how would one do that?
Yeah, I don't know, how you would get here or how you would habitate. The environment's pretty harsh. And how you would travel or all that. And then, there's a certain security situation involved, so you would have to have some level of clearance. I can't just, invite anybody in here that I don't know. That's forbidden. So,
of course, yeah, I know, and you've had trouble with that in the past. I was just wondering because I figured I'm not the only person out there who thinks what you're doing is amazing and, wants to contribute more than just money. But thank you very much. That's all I had.
Great, thank you. Let's see. Okay, if your phone number ends in 8610, I'm going to unmute you right now if you want to go ahead and introduce yourself and ask your question.
Hi, my name is Jonathan Dallaire. I'm from Palm Springs, California. Good evening, Aaron and Eric. Thank you for having me on your phone call here. I've been recently... Yeah, thank you. I've been reading the paper "Energy Defined" by Dr. Dollard here, and I had a couple questions about that.
Okay.
And one of the concepts I got was if I had a rotating magnetic field, and depending on that frequency or the amount of time revolutions per second. That would in turn create an electric motive force, which is voltage, I guess. So magnetism in turn creates voltage, and then
it creates electromotive force. Voltage is the units, but electromotive force is the proper term.
Okay, and then for instance, like an electrostatic generator, that would be the dielectric field under frequency, and would that create then amperes or amps?
Yeah, that creates what's called the displacement current.
Okay, so
you have four. You have four components. You have two voltages. That's why there's so much confusion about this subject, because this knowledge no longer exists, but voltage is a misleading term. That's just the unit. So you either have electromotive force, which is a magnetism varying with respect to time, or you have an electrostatic potential, which is a ratio between the quantity of dielectric induction and the capacitance of whatever is holding the dielectric induction. So the electrostatic potential and the electromotive force are two completely different things, but the term voltage confuses the two. Now, it's the same thing with current. You can have the conduction current, which is basically the amount of magnetism in the system divided by the inductance holding the magnetism, or you can have a displacement current, which is the dielectric induction varying with respect to time. So the electromotive force and the displacement current are time variant, and the electrostatic potential and the conduction current are ratios or proportionalities in the field itself.
Oh my goodness! Because how I kind of got it was in a way one can create the other, but I guess I need to kind of read it a little bit further.
Well, yeah, I mean, if you have a displacement current flowing through a capacitor, and then that connects to a transmission line, well, that displacement current then becomes a conduction current when it gets in the transmission line, and then it can create a magnetic field. So in that way, the dielectric field is consumed into the displacement current, which then turns into a conduction current when it gets outside of the capacitor, and then that energy in turn produces the magnetic field, and then the whole situation is also reversible.
So when I start learning about these different parts or components now, these fields, I can then, in a sense, get into the synthesis part that you speak of.
Right.
Which now most of us think that the generation of electricity comes from giant magnets moving around in a rotation, and that magnetic field is the only way that I'm going to get any sort of work done. But in a way, there's other ways to skin the cat, and we're not even looking at it. But now, if I were to go with the displacement current way of generating electricity, would I still have the opposing force that would be found like in a generator conventionally, where the load is felt? Or is that what you're trying to get at, where they're like...
That's never been determined. So, the electrostatic generator, like the Van de Graaff generator, for example, that's also a generator of electrical energy, but it becomes very difficult to define the relationship between the forces and the energy. Tesla even wrote a paper on that when the Van de Graaff generator was developed, is that he could not pinpoint the correlation between mechanical energy and electrical energy, that it seemed to be inaccessible, but he felt very confident because of the law of conservation of energy that the two were tied together. But that's something that needs to be determined, is what's going on in an electrostatic generator force-wise. Is the mechanical energy in equal to the electrical energy out? That's not something that you're going to find any information on, because no one's ever done those tests, and no one's interested in doing those tests as far as academia and what have you.
Oh, can I ask one more question about transients and impulses and whatnot?
Yeah.
If I have time.
Go ahead.
I've been looking at using capacitors basically to go in series of the 60 hertz AC signal, so I can bring what I'm hoping, I guess, is the voltage down, or the voltage and current down, so that capacitor doesn't blow up, instead of using a resistor. But they were saying that if I do not have a resistor there, I could have transients that pass through that dielectric and damage the LED. Now, is there a relationship between these transients that are passing through that capacitor and that resistor that's absorbing those transients to like a hairpin circuit and a light bulb?
Well, I don't know, you got kind of a number of things mixed up here, but you have to remember that the current through capacitor is proportional to the rate of change of the potential or the flux involved. So at 60 cycles a second, it's going to exhibit a certain impedance, which might be right to light up the LED, and then you won't be wasting any energy in heating any resistor up. But a harmonic, like the third harmonic of 180 cycles per second, if that becomes predominant in the system, or if there's a sudden change in the potential that occurs, in a course of hundreds of microseconds, and all of a sudden that current's going to skyrocket. The capacitor is basically going to drop out of the circuit, and the LED is going to be best hooked to the power line. So if you want to do something like that, it's better to use an inductance coil than rather than a capacitor.
I see. So I'm just mistaking a short circuit because now the capacitor is just letting a high frequency pass.
Yeah, the admittance of the capacitor is proportional to the frequency. So at DC, the capacitor has no admittance. It'll just charge up, and that'll be the end of the deal. But if you have an infinite step from zero voltage to some defined voltage that occurs in microseconds, well, then all of a sudden the admittance of the capacitor is infinite, and you might as well just have a wire connected across it, and then there'll be no more opposition to current flow, and then whatever on the load end will be destroyed. So if you use an inductance, the situation is the other way around. The faster the variation, the more impedance, but the problem is inductances are heavier and they're expensive, and then it starts to become kind of impractical. But in any case, that's what's used or was used in the real days of electricity. Is fluorescent lamps have a behavioral pattern similar to LEDs. So an inductance coil was put in series with them, so there wouldn't be energy wasted and all those kind of complications. So the inductance is the way you want to go if you're going to try to go for a ballasting that doesn't result in the generation of heat and the wasting of energy. Otherwise, the best thing to do is just to hook all the LEDs in series so it matches the line voltage as close as possible. And then you can use a nonlinear resistance, such as a small incandescent lamp. So its resistance will increase as the current flow increases. So when it starts to reach a red heat, the resistance is several times what it was when the lamp was cold, and then it acts like a safety device or a buffer to prevent damage to the LEDs. I think what they do now is they basically just build an inverter that works as a constant current source to supply the LEDs, and then that basically separates them completely from the frequencies and what have you of the power line. But then at the same time, it creates a massive quantity of electromagnetic pollution and screws up your AM radios and what have you.
Oh, okay. And just on the transients that I was thinking of, that only comes into play when it's a destructive discharge, and then I create a new type of current, which is basically the ether and momentum. Or
well, you're creating a displacement current. So the electrostatic field is changing because you're charging it or discharging it, and during that interval, it's like if you take a capacitor while it's discharged and you connect it directly across the constant potential, you're going to get a very loud snap. You're going to get about the same snap that you would if you discharge the condenser. So when you first turn on the switch to this thing, the capacitor is a short circuit. That's your step transient, and you'll burn out everything that's connected in series with it.
Okay. Well, thank you very much, Dr. Dollarton, for answering my questions. You've you've helped me to see more about the electrical side of things or electrical engineering than any one of my conventional teachers have. But in turn, you've also allowed me to see conventional science a lot better. So thank you very much.
Okay, you're welcome.
Okay, thank you. So if, let's see, Eric, we're on an hour and 9 minutes right now. Do you have time to keep going? You up to it, or?
Yeah, I might as well keep going. That's why I drank all this coffee.
Okay. So if anybody has any questions, if you hit 5**, that'll give a little flag next to your phone number, and we'll know you have a question. Okay, if your number is ending 7947, I just unmuted you. Go ahead and introduce yourself and ask your question.
Hi, Aaron. This is Jeff Mineho, number one seat for this year. Hey, Eric, I really appreciate all your stuff recently on the J.J. Humpson stuff on the time and space and lifespan. It's going to be put to good work in the next few months on a couple different things. Now, I have a very important question on your research before. dealing with some brain questions. Can you tell me the volume of area that your orchestra encompassed for your 10 kilowatt Bolinas measurements with your Chinese symphony? Can you give me a guess? 3 or 4 feet? You know.
Oh, I'm not.
Like a cosmic bulb size, small, big.
Oh, you mean what was inside the lamps?
No. You said you could feel like the vibrations of the different frequencies, like an orchestra. They were in different locations. You know, just like.
Oh, that's the Earth stereo. That's a shortwave reception.
Oh, okay. What volume? What area was that? What sort of cubic volume would you say that was?
You're talking about the entire Earth ionosphere transmission waveguide.
No, but near you, you said that you could almost like reach out and touch.
Oh, yeah, it was basically a 10 by 10. The terminal building at Landers.
Okay, all right. So they were all within that 10-foot volume with the 10 kilowatts of discharge of the dual Tesla.
Oh, there's no 10 kilowatts of discharge. It was audio amplifiers and shortwave radio receivers.
Oh, so that didn't have any cosmic induction generator work with it.
No, it's just simply a.
Oh, I see. Okay.
VHF receiving system. It's a special receiver where you have 2 antennas, and you receive in stereo, and the Earth becomes the concert hall.
So how much phase shift was there between the two, would you think?
Well, it depends on ionospheric conditions, but there could be any phase shift. It could be a few degrees. It could be multiples of cycles. It depends upon the situation. That's what causes such a unique type of stereo.
Yeah. Well, I was just curious because you said it was unique that one time. That was really stood out real well. So you don't really have the okay. Can you tell me the order of books if you're going to get to the Hans Kaiser stuff at all, or is that like way down the list?
I didn't quite get that question.
The Hans Kaiser rewrite.
Oh,
is that
okay.
Way down the list.
I've kind of put that on standby right now because I'm so busy doing this other stuff. I've gone through. I read the book. It's kind of very convoluted about how it goes about things, and there are a number of significant errors in there. The complication is the copies I have, a lot of because it's all this tiny, very tiny handwriting and whatever, a lot of things just simply can't be read. And
you need a new copy? Because they reprinted his work, I think. I found one location where they reprinted.
I need a copy that's legible.
Okay, all right. I'll try and find a
copy that was legible. That would help, but I'm not planning on starting that until after this whole presentation's over and what have you. That's next year's project.
Yeah, that's fine. So what books come out next? 1, 2, and 3, and then some Versa?
Well, the Versa thing is the Hans Kaiser project.
Oh, okay. All right. Good.
So right now, I'm working on the extraluminal and the upcoming presentation, and that's all directed towards the Alexanderson antenna project. So it's like killing 3 birds with 1 stone.
Right. I saw the bench video in December.
There's so much work involved. Everything has to be all coordinated so that 3 or 4 different things are taken care of with one basic program.
On the December bench video that I watched, do you know what sort of bandwidth you're going to end up with? 30 or 40 kilohertz on your bench setup for your flat curve with the cancellation of everything?
Well, the passband, I don't have to look at my notes, but the passbands go from about 300 cycles to 3,000 cycles on these. Okay,
so it's about 2,700 hertz. Okay.
Yeah, the Finnish networks that I used at Landers, the system operated between 300 cycles and 30 kilocycles.
Okay. All right. Okay, Eric. Thank you very much, and I'll see you when I get there.
Okay.
Hey, thanks, Aaron, for the motor book. I got some guys working to try and combine all that stuff.
Okay.
Cool.
Thanks. See you. Bye.
Thanks, Jeff. Okay. If anybody else has any questions, you can hit 5**, and that will flag your phone number. Let's see. If your number is ending in 8661, I just unmuted you. Go ahead and introduce yourself and ask your question.
Hey, Eric, Ed in Lincoln, Nebraska. I was wondering if you had any writings about electric motors, AC electric motors and armatures that I could read about.
No, I haven't really delved into that. So my field is more transmission engineering than electrical machinery. So I haven't got into the motor generator stuff in depth.
Okay.
I would have to refer to Steinmetz.
Yeah, okay. I'm familiar with that.
Okay. Do you have any other questions?
No, that's all I got. Thank you.
Okay. Thanks, Ed. Okay, let's see. If your number is ending in 8441, go ahead and, let's see here. Go ahead and introduce yourself and ask your question.
Hey, Eric, Francis from Nebraska again. Eric, do you believe that weather control is possible, or that anyone is controlling the weather or manipulating the weather now, today?
No, I don't really think that's going on. I know a lot of people do, but it's this contrails and the rest of it, but it's really all that's a bunch of malarkey. And the HARP doesn't really seem to have anything to do with it. It's not really on the air that much anyway. I don't know what the China HARP is on the air for. It seems to be the China HARP is mainly for jamming. None of the conspiracy theorists seem to want to talk about the China HARP. So that shows how much they're worth, because it's really playing havoc to the users of the HF band. It's very disruptive, and it has no regard for whoever it lands on. But most of this stuff seems to be for jamming purposes. The United States HARP allegedly is for manipulation of the ionosphere, even though I don't know if they have enough power to do that or whatever. There could be a secondary effect of changing the weather, but I think if anything is changing the weather, it's just the sheer pollusive output of internal combustion engines, particularly the international airline traffic, that would be causing any weather changes.
Okay. Do you have any other questions, Francis? Francis? Okay, I'll go ahead and mute you out. If you want to ask another question, go ahead and hit 5 asterisk. Let's see. It doesn't look like anybody else has any questions. If you do, go ahead and hit 5 asterisk, and if not, we can go ahead and wrap it up. 5 asterisk, that'll let me know you have a question. Give a couple seconds here, see if anybody, okay. So if your number ends in 7711, you're unmuted. Go ahead and introduce yourself and ask your question.
Eric, good morning. This is Bernie up in Cotati, California. I'm sure you know where that is.
Yeah, I used to have a radio station at Sonoma State College.
Yes, you did. That's right down the street. Call signs KK6BAR. My old lady has been listening to your voice playing on my computer for the past 6 months, and now I'm on the phone with you, and she's rolling my eyes. I just wanted to ask if you were going to talk any more about your concept of hollow Earth, that there is no core.
Well, that's my belief.
Heard you say that yeah, me too. I've come to the same belief as well. I was just wondering if you were able to elaborate more on that idea.
Well, yeah, I mean, in my mind...
And why you have that idea? Like, how did you get to that point to understand that concept?
Well, it's that idea's been around for a long time. It's one of those things that, ran around in borderlands. But the observations of my seismic monitoring system at Landers, which was the mechanical end, it was basically a seismograph, a somewhat conventional seismograph in the pens and the inks and the pickup and all that, but I had a power amplification of roughly 10 to 100 million in between the pickup and the chart recorder, so that I could watch the entire Earth vibrate. And after each one of these major events, like in Chile or Japan or whatever, the Earth is seen to ring like a bell.
Right. Okay.
So if the Earth is going to ring like a bell, it would have to be hollow, because if according to the theory that there's this viscous molten rock material and a liquid core, and all that,
right. Yeah, it doesn't make sense.
That would dampen out all the vibrations. Now, just recently, Steve McGreevy played a recording for me. I think he's got this on his website of what somebody did back in the days when this stuff all used to go on magnetic tape and wasn't digitized. Is someone took one of these super slow instrumentation recorders and then took the tape and put it on like 15 inches per second or whatever the highest speed, and the earthquakes are these banging noises, and it sounds like basically sounds kind of like an automobile body. It has a metallic sound to it, and it's
like you're banging on the fender or something, right?
So it's again there's this kind of the same boundary condition, and then just from all the decades of me building things and dealing with physical science and mathematics,
just coming to understand
is this concept that the gravity keeps getting stronger and stronger and stronger until you get to the singularity in the center where it's of extraordinary magnitudes has never really made any sense. And in my mind, from my experience with the physical world, is there would have to be some point in which the gravity reverses. So there would be some kind of average value point where all of a sudden the vector going towards the inside, the pushing would get weaker and weaker, and then you would reach a null.
Right.
After
and
that
then
point, then there would be an internal surface, and then the gravity would go back out the other way again.
Exactly.
And it's quite possible it could be a habitable environment with an internal ocean and a sun, which I refer to as a Farnsworth star, inside the center of the Earth.
Right.
There's actually a movie made about this called Journey to the Center of the Earth, where they got to this interior world, this counter space world, where you're standing, your legs are pointing outwards, not inwards when you're standing, and the gravity would be less there, and that would be a place where you would expect, like dinosaurs and all these things, that you would figure are really too big to operate in the gravity on the surface of the Earth. It could have very well come from inside the Earth. But, of course, these things are all speculations. But from my observations and my experience with the physical world, that's how I see it.
Right, I agree, too. I'm working on some coil designs that kind of replicate what you were just saying. I'm not sure what these things will do yet. I haven't plugged them. I haven't powered them up or anything, but it's a very interesting and new concept. I've never seen this coil design anywhere else. Let's see, what else did I want to ask you? Did you ever, the diagram, I'm sorry, I stutter a little bit when I get excited. You know the diagram where you see, it's a drawing, you see the concentric rings to the dielectric center, and then you see the electric dotted line going from pole to pole. You know what diagram I'm talking about?
Yeah, the electric field diagram, right?
The electric field diagram, right. And you see the two poles in the center, to the left and the right. Did you ever think of a concept where it would not be, it would kind of violate the right-hand rule of, the magnetism at 90 degrees. Do you ever think of the concept that it would be in a spiraling form around the conductor?
Well, not around the conductor, but around the system of conductors. Not
right.
The system of conductors.
Taking that diagram and connecting those concentric rings to make it look like a spiral, and then it would spiral all the way to the I have a picture of it. I could send it to you. It makes perfect sense once you see it.
Yeah, but I don't think it's I don't think that's physically realizable.
You don't think that's actually what's really happening physically?
No, not
in the fields as the fields are. Okay. I was working on this idea.
Only if there was some kind of rapid oscillation going on, and probably more than two conductors, or it would be, it's probably some way that it could be arrived at that the velocity of propagation through the lines of force was such that it couldn't react.
It leaned. It had a
flux, but that's all. It doesn't really sound feasible.
Huh. Okay. All right. I'm going to send you the picture anyway, that you take a look at it. You might, I don't know. Once I looked at it, I showed it a few other people, and they were very taken back by it and had to think for a while. And I haven't heard back yet, but
yeah.
It was an interesting concept. But anyway, I just wanted to jump on, introduce myself, say hi. I'm from the same area. I've been to your radio station a couple of times. Even before I even was in this realm of work, I've been an electrician, ham radio. I've worked for Sprint, Ericsson. I've been in every communication shelter in Northern California. And I probably crossed paths with you in the past. So, I don't know. I have a lot in common.
When I was at Sonoma State, that was like 30 years ago. So
yeah,
you wouldn't. The radio station was on the FM broadcast band. It was called KSUN.
Yeah, I don't remember that one.
And it was kind of famous there in Cotati because I had this massive RCA receiving system, this stereo receiver, and instead of using ABC or CBS News, we used to tap in on shortwave stations from all over the world, and use them for the hourly news broadcast. It got on the front page of the Cotati newspaper back in I forget when that was, maybe 1978, 1980, 81, somewhere back in there. I don't know if that newspaper's still there. If you could find that photograph, I'd be interested in getting a copy of it if they keep records.
Sure. I'll dig it up. I'll look for it then. I'll go to the library or something, see if I can find it.
Otherwise, when Sonoma State College got demonopolized and became Sonoma State University, everything I put together was destroyed.
Destroyed, yep. I understand completely. Oh, gosh, I had like 10 other topics I was going to talk about, but now I forget them. I know what I have to ask you. Would you ever care to have a visitor? I kind of feel like maybe we're the same cut, understand the same things. I do have a big badass truck with lots of tools I can load up. I'm kind of a gnarly dude. I can live outdoors too. I have some Homeland Security. I have a Homeland Security clearance card. I'm not one of those freaky dudes. Anyway, I would just like to come down and hang out and see what you got going on, and maybe share my ideas and then talk about what you got going on too.
Yeah, well, you'll probably have to meet me in Lone Pine initially.
Sure. Yeah, at a coffee shop or something like that.
Yeah.
Yeah. All right.
So you write.
All right, well, I'll reach out to you.
Send a letter to Lone Pine, and then we can make arrangements from that point.
All right. Okay. Yeah, I'd really like to show you the coil design I'm working on. It's pretty intriguing. All right. Well, I'll just reach out to Denny in the future. Then when I'm sick right now. I'm taking medication and stuff like that, so I can't really do much. But yeah, once I get better, I'll write to you, and maybe I take a drive down there. It'd be 5-6 hours to get to Lone Pine, right?
Yeah, it's probably more like 8 or 10 hours.
Oh, all right.
Yeah,
well, either way, I'm just saying. Down the road.
You either have to go through Reno or you have to go through Bakersfield.
Right. I know both routes, yeah.
Yeah.
But
what was your name again?
Yeah, Bernie Riley.
Okay.
KK6BAR. Are you still in the radio? Are you still operating?
Well, my PRC, I can't seem to find a working PRC 47, so I've been off the air. And then my base station KPH, that got and destroyed several years ago. So
we probably know
RCA is no more, and so I can't. It's really hard for me to be active to get another HF antenna field back together. It's not. At an estimated cost of $50,000 per antenna, 15 acres of land minimum, I am not seeing that in this lifetime.
Right. Yeah, I hear you. Hey, do you know anybody at the Elkins Training Institute in Tamales? Do you know any of those guys? I've
divorced myself of that whole part.
From that whole area, huh?
Yeah. We call it the occupied territories.
It has become that. You're absolutely right. All right, man. Well, good luck to you. Best of luck. I hope you feel better with your eye and everything. I didn't know you had a bum eye now. I know what it's like to try and work and not feel well, and
yeah, it was
appreciate that kind of that kind of suffering isn't fun. So I'm sorry to hear that. All right, so I'm going to head out, and it's nice talking to you, and look forward to meeting you soon. Hopefully, I'm going to get out to what is it, Ohio? Is that Ohio for that conference?
Idaho.
Yeah, that's what it was. Yeah, hopefully I'll get out there and see you out there.
Okay.
Okay, thanks for your questions, Barney.
Yes, sir. Yeah, take care, you guys.
Okay, thanks. Let's see. Okay, the number is ending in 4638. Go ahead and introduce yourself and ask the question.
Yeah, hi, Aaron. Hi, Eric. It's Bruce up here in Rhode Island. Eric, one of your videos, I remember hearing this right. You can validate it for me. When you were running your Tesla coil setup and you were burning the patterns in the wood, I think you said that you were exciting the resonant transformers with a cathode modulated power oscillator. If that's what you were using there, is that a reasonable way to try to generate a pulsed waveform?
Yeah, it's called a keyer. So you turn the RF amplifier on and off with a modulator or a keyer.
Okay.
So the devices, there's MOSFET devices available this day and age to do that, so you don't have to use all those hard-to-find radar modulator tubes.
All right, and you'd use the MOSFET in the
or
cathode circuit of the vacuum.
If you don't want exotic waveforms, you can just use mercury-wetted relays.
Okay. Yeah, and what sort of what kind of a rate can you get with turning a relay on and off? What kind of
well, you just have a
pulse rate.
A square wave generator or a controllable pulse generator, and you just run that into the relay coil, and then you take the relay contacts and you hook them in the cathode circuit of the power amplifier tubes.
Okay, I get you. If the coil system's tuned up, to a couple megacycles, what sort of pulse rate would you generally use?
About 10 pulses per second seem to be optimum for a lot of that type of stuff, with a duty cycle of about 20%.
Okay. Is that what you were using to burn those patterns, or were you playing music through that system?
Well, I think when I demonstrated in Los Angeles, I was using a plate modulator and using music, which of course is filled with all kinds of transients.
Yeah.
So that will make a pattern, but the thing is to have the rectangular pulses in the proper succession, I think would make it work better, because it's more regular and controllable.
Yeah. All right. Well, might pursue something like that at some point. All right. Well, thank you. I'll let you go and wish you well.
Okay. You're welcome.
Thanks for your question. Let's see. 8441. Yep. Yeah. Go ahead.
Yeah. Eric, Francis from Nebraska again. Do you think Tesla was able to generate earthquakes or cause earthquakes, and do you think any government today has that power?
Well, he was doing it with his mechanical analog of his Tesla transformer. I suppose, if somebody wanted to build some massive facility and try to trigger earthquakes, they could do it, but I can't see why anyone would want to do that, because what would happen would probably get out of control. So I don't think that's going on.
Okay, that's all I had. Thank you much.
Okay.
Okay. Well, let's see. We're here at an hour 35 minutes. Nobody else has their hand raised. Let's see. I did want to mention that there is a Crystal Radio Initiative contest for the conference. If anybody is not familiar with that, Eric has a Crystal Radio Initiative, which is using a Tesla-style crystal radio to receive AM transmission through the ground. And the goal behind that is to be able to power either little light bulbs or motors and that kind of thing. VR Green, who's a Simon Davies in Energetic Forum, showed his replications there with pictures and diagrams of his setup and comparing the transmission speed between the ground transmission and the above ground. If you want to learn more about that Crystal Radio Initiative, that's at crystalradioinitiative.com. And we have a contest right now for the conference, which is whoever wants to participate in that, whoever has the best setup or the best results, they can have free admission to the conference and a $400 cash prize. And you can read more about that at one of the blog posts on the news tab at EnergyScienceConference.com, which is a conference coming up in July 8, 9, and 10, where Eric will be presenting again. And you can learn more information on that website, EnergyScienceConference.com. Let's see. We do have in Eric's books, notebooks number 1 through 3 out of that series, which is an extension of the extraluminal transmission presentation. We plan on releasing these notebooks 1 through 3 this coming Tuesday, and if we are unable to launch them on Tuesday, they'll probably be launched on the 25th, Thursday at the latest. Let's see, we have a couple more questions here. If your number is ending in 3183, I'm going to unmute you right now if you want to go ahead and introduce yourself and ask your question. Yeah.
Hello?
For your number. Yes. Go ahead.
You can hear me?
Yes.
Is this Aaron?
Yes.
Okay. Hi, Aaron. This is Byron Brubaker. We've talked in the past on Facebook. I had a question for Mr. Dollard concerning the Crystal Radio Initiative. What is your best results so far?
My personal results?
Yes, sir.
None, because I don't have any equipment to do it with.
Okay.
I'm getting other people to do it.
Okay. I myself, I like to tinker. I just like to build and play. I've been doing this for, since 1986 is when I really got into this. And I just had this knack for reading Tesla's patents and understanding what he was hiding. We know they get to keep a secret, but they put it right out there in front of us, right under our nose. If we read it and do exactly as instructed. Does it have to be an AM crystal radio? Can we just use potential difference hoisting an antenna?
Well, that kind of defeats the purpose of the whole thing because you're trying to receive out of the ground, not out of the air.
Well, I'm just coming at Tesla's Radiant patents, the two he has, and just coming at it that way. And instead of having to lug a big antenna around, I just use what I'm paying for out of my outlet as the signal source to create to mimic a hydraulic pumping action on the secondary. So we can, what we're using is a hairpin multiplying circuit so that we hairpin the secondary with capacitors, and then that creates the polarity reversals that pump charge electrons from ground connection, and then we multiply it there. We can get as much voltage as we want as far as output without dragging a load or a heavy load on the outlet. So it doesn't cost us anything extra from the electric company. We're just using the hertz as the signal source. So I didn't know if you'd be interested in that, if that would be something for you to look into, if you'd be interested. We'd appreciate it if you give it a look over, and we'd appreciate your opinion on it.
Well, you have to send the diagrams to Lone Pine.
Okay. Aaron, would that be possible to just relay information through you to Eric then, or?
Well, if you go to Eric's website, ericpdollard.com, and in the right column, there's a Lone Pine general delivery address, and if you just put it in snail mail to him, that'll go straight to Eric. He checks that box maybe about once a week, once every week and a half or so.
Okay, that'd be great.
Yeah, that's the quickest way to do it.
Okay.
And I do want to mention in energeticforum.com. There are some posts of the Crystal Radio Initiative experiments successfully replicated, and in the past, when Eric first proposed the contest, the ultimate goal was to light a 100-watt bulb, but of course you have to have a pretty massive ground system to even start playing around at those levels. But there were people coming forward that had that were able to power small light bulbs and even small motors. So
sure. Yeah, I'm aware of that. Yeah, I just come about it a different way. That's really all I did. One thing that I've lit up was one of those old laser tubes out of an old laser disc player, one of those little ancient ones. I think it was labeled NEC, but I didn't have any problem with that. And we just like to build and play, and we just kind of go from there. I did take this circuit to the Stan Meyer conference that was in Bremen, Ohio this past November, and I displayed it there. And I'm kind of a nut, a cut up and quirky and awkward, but that's really all I like to do is build and play. But we did show it there, and hoping that the principle is enough to convince others to run with it and benefit from that. So, yeah, I will make sure that I get that information to you, Mr. Dollard, and we'd love to hear back from you. We'd appreciate your comments.
Okay. I'll write you back after I look through the stuff.
Okay, and congratulations on your seismic work. It's very commendable, and I love the work that you've done since the Borderland days. Keep at it. I look forward to seeing more things and new stuff from you. So, thank you.
Okay, you're welcome.
Thanks a lot, Byron.
All right, thank you.
Okay. Thanks, Byron. Okay, let's see. If your number is ending in 9151, you're unmuted. Go ahead and introduce yourself, and you can ask your question.
Okay, can you hear me okay?
Yes.
Okay, thank you. Yeah, so John from Alexandria again. I know we're kind of winding up here. I just wanted to ask, are you planning on doing more of these calls in the future? Because I just think they're a wonderful way to interact with you, and even if they were infrequent, I would certainly tune into every one of them and kind of work to prepare some quick, intelligent questions that I would have. The work I'm doing that just started actually with this other fellow who is just really impressive to me because he actually builds everything, doesn't just talk about it. We're going to probably have some questions we'd like to pose, and I just want to know if it's going to be available, and then maybe if a recording of these things is going to be somewhere we could go and check.
Yes. So if you go to my let's see, on my YouTube channel is youtube.com/Aaron Murakami, and we've done 2 or 3 of these live calls a year, and usually I'll put those up on YouTube with maybe, a couple pictures, not usually a full slideshow or anything unless I really have to reference something, but you can go through that channel and look at some of the older calls and interviews and stuff that we've done. And we do plan on doing more. It just depends on whenever Eric's schedule and my schedule can sync up when he happens to be back at the shop. And we can do these. And so, there's no regular schedule or anything. Just kind of.
That's fine. As long as they come up from time to time, I'll keep an eye out. And I have looked at just about all the stuff I could find that has your name on it, Eric. So I just want to, give you a little word of encouragement. There's a lot of people out here like myself that, don't fit into society very well because we have strange ideas and a lot of them carry some weight. I've been put out of so many places, lived in my car too. I was homeless for 2.5 years. I know what a shit it is to, be without resources and have, a good head on your shoulders. I just want to say that we appreciate that you hang in there and you do what you do.
Okay, well, thank you.
Hey, thank you. Let's see, it's about 12:46. I guess I might as well just go for about another 14 minutes and wrap it up at 1 o'clock.
Yeah.
2-hour call. Okay. Let's see, if your number is ending in 3183, you're unmuted. Go ahead and ask your question.
I'm sorry. This is Byron again. I didn't raise my hand.
Oh, yeah. Okay.
I apologize.
But okay, no, I must have not have unselected that. Okay, thanks, Byron.
Thank you.
Let's see. Okay, for number 8441, I believe that might be Francis.
Yeah, thank you, Francis from Nebraska. Eric, do you choose a feral existence, just because it's healthier? You recommend it for the rest of us? Or, like, even if you were a millionaire, you'd still live away from all those harmful cell phone tower, radiation and stuff? Or you just kind of do it out of necessity, and if we could ever raise enough money to get you financed like you deserve, you'd move back to the city and, live perhaps what most people consider a more normal life?
I have no interest in living a normal life. So the feral existence is the existence.
I'm sorry, I didn't hear the first part. You have experience living the normal life and you don't like it? Was that what you said?
I have no interest in this thing that people call lives. It's viewed as an impediment. So I've lived in my Toyota Corolla for 29 years, and it's just fine. I can't wait to get back outside and do it again next week.
Okay, I can appreciate where you're coming from. The beauty of nature. It's just that we'd all benefit tremendously by having you around more people and lecturing and having a big expensive lab like Tesla that we could work in 14, 15 hours a day, and et cetera.
Yeah, well, if I was working 14 or 16 hours a day, it would be, probably on this stuff here. But I'm not really enthused about living in society. It actually disgusts me, to be truthful.
Okay, did you have any other comments or questions, Francis? Hello?
Can you still hear me okay?
Yeah, I can hear you fine. Yeah, do you have any more questions or comments?
I hope you do a short little pamphlet or book on your philosophy of life sometime, Eric. That's all. Thank you much. And likewise, Aaron, you guys have obviously have some good philosophical thoughts. So please do a short little pamphlet or whatever article on the Internet so that the rest of us can get wiser along those lines too. I do have your article on synchronicities and stuff, Aaron, and I really appreciated that. That's all I have. Thanks a lot.
Okay, thanks, Francis. Let's see. If your number is ending in 9159 or 9151, did you have a question, or maybe I forgot to lower the hand there?
Oh, no. I'm fine. Thank you.
Okay, thanks. Okay, let's see. We're getting on about an hour, 50 minutes now. We're going to go ahead and wrap it up if nobody else has any more questions. If you do have a quick question, we'll take maybe one or two more. Hit 5 in the asterisk, and that will let me know that you want to ask a question. And if not, we'll go ahead and get it wrapped up here. Okay, so let's see. I will be putting out one more little video segment that I filmed of Eric talking about some old vacuum tubes or some old radio tubes when I was down at a shop in December. I'll see if I can get that out in about the next week or so. We did recently release the Notebooks 4 and 5. That's on powerofether.com, which is the J.J. Thompson and the Steinmetz notebooks, and then notebooks number 1 through 3, which actually come before those. We're going to release those this Tuesday or Thursday at the latest. If you're on any of the mailing lists or in Facebook or whatever, you'll definitely see the announcements on those. Eric is going to be speaking at the conference, 2016 Energy Science and Technology Conference. His presentation is going to be electrical transmission and multiple coordinate systems, and so it's going to be highly mathematical. It's still going to be algebra, but it's going to be more technical than the extraluminal transmission talk, which was more for the layman and kind of to orient everybody. That talk is probably going to be about another 4-hour presentation. Let's see. Eric made reference to Steve McGreevy a couple times in his receivers that can hear, these so-called earth sounds. If you want to learn about Stephen McGreevy's work, his website is auroralchorus.com, AURORAL chorus.com. And you can learn about his work there. There's a lot of different sound samples of these sounds he's picked up with his different receivers, and there's quite a range of different kind of sounds, and depending on the weather condition and location and that kind of thing. And Stephen McGreevy did a presentation last year at the conference, which is at naturalvlfradio.com. And also in December, when I was down at Eric's shop, I did it was maybe a half an hour interview with Stephen McGreevy. That's on YouTube. If you go to my channel, youtube.com/Aaron Murakami, there's maybe about within the last 5 videos or so I posted, you can see the interview with Stephen McGreevy. Also, I want to mention on Eric's website, which is ericpdollard.com. P stands for Paul, Eric's middle name. So ericpdollard.com, and in the right column, there is a PayPal donation button if you would like to click that and donate anything through PayPal. Also, you can send donations by check or money order to the address that's on his website, which I believe is a Davenport, California address. That's where Justin Miller can receive those and send those into the nonprofit's bank account. He is the Secretary and Treasurer of EPD Labs, which is a nonprofit organization. It is a 501c3, so any donations are tax deductible. And Justin is also the one who primarily works out in the field with Eric when they're working on the transmission lines and stuff. And let's see, do you have any final comments or announcements or anything, Eric, before we close it up?
No, I think we pretty much covered everything.
Okay. Well, I guess we'll go ahead and end with that. And Eric, appreciate your time, and thank you everybody for being on the call. And we'll
thank you. Hello. Hello.
Yeah. Well. Yeah. Hello.
Oh. Just want to introduce myself.
Yeah. Did you have a question?
Yes.
That's very much.
Yes.
Okay. Yeah. Go ahead. Go ahead. Yeah. Hey, what's the last 4 digits of your phone number so I know not to mute you out?
Okay, it's 2852.
Okay. Yeah, go ahead and ask your question, and then we'll go ahead and wrap it up.
Yeah, I just want to mention to you that my name here is Alan Frankel, and about a little over 2 years ago, 2 years, about 3 months ago, I moved to Arizona. I'm in the city of Surprise, and I just want to comment to you that I hope you really get this seismic project really going, including the telluric antenna. I gather you said that the the telluric antenna itself is complete, or did you want to add something to it? Over?
The telluric antennas are still under construction, but everything that's needed is available now. It's just a matter of the time and money and positioning, the weather, and what have you, to be able to produce the end result.
Yeah, okay, very good. Yeah, I would like to order some of your books. The only problem is that I don't have the resources. I'm still looking for a job. It's a long story why I moved here, but I'm just wondering if sometime I can call you personally.
Yeah, that might be difficult. The best thing to do is to write.
Okay, get on your website and just email you?
No, I don't subscribe to email or silly phones or pecking devices. You have to write to my mailing address.
Yeah, if you go onto Eric's website at ericpdollar.com, in the right column, you'll see an address in Lone Pine, California, which is a general delivery address. And just drop it in the regular postal mail, and Eric will receive it.
Okay, very good.
And yeah, that's
all right.
Best way
Thank
for anybody. You. Yep. Okay. Well, thanks for being on the call, everybody. And I'll get this up on YouTube as soon as I can. And thanks a lot, Eric.
Okay. You're welcome.
Thanks a lot, Eric.
Okay.
Thank you, Eric.
Yeah. Thanks, Eric.
Okay. You're all welcome.
You
all right,
too, Eric.
Take care.
Okay, so it's 11 o'clock. I'm going to go ahead and get started. It's 11 o'clock Pacific time. This is February 21st, 2016, and I have Eric Dollard on the call. Eric, can you hear me okay?
Yeah.
Okay, we might as well go ahead and get started here. Let's see here. Back in early December, I went down to Eric's lab and spent a few days there and filmed quite a bit of stuff. We went out to the seismic lines and did a little tour around the shop so everybody can kind of see all the equipment that's been accumulating. And also talked a little bit about Lone Pine Writings and did an interview with Steve McGreevy. We did a little shoot of Eric doing the network experiment on the bench. And I think the only little video segment I have left to put up on YouTube, which I'll do here in the near future, is Eric was talking about some old tubes in a old reference book, and we'll just put a description in the YouTube video what that's about. But that's kind of a little short, couple-minute segment. Also, let's see. Eric is going to be speaking at the 2016 Energy Science and Technology Conference in Hayden, Idaho. That's going to be in July 8, 9, and 10. And the website for that is energyscienceconference.com. We limit that to about 150 people, and there's already only about maybe 40, maybe 41, 42 seats left. But that is 4.5 months away, so there's plenty of time to send in payments and everything, and we'll cover a little bit about what Eric's presentation is going to be about. About 2 weeks ago, we released notebooks 4 and 5 out of a 5-part series. Actually, Eric is already on notebook number 8. So, Eric, do you want to take a minute and kind of explain actually, before going into the books, do you want to talk about what your presentation at the conference is going to be about?
Basically, the presentation is going to be a continuation of the extraluminal presentation.
Okay, and that's the talk you gave, I think, in 2014?
Yeah, the year before last.
Okay, so in 2014, the presentation was extraluminal transmission systems of Tesla and Alexanderson. And do you want to explain, maybe take about a minute to explain what that presentation was about and what you're leading into with the next presentation?
Yeah, that presentation was kind of a layman-orientated pictorial presentation to lay the groundwork of the history and the basic terminology, how this factor of the speed of light came to be and how it entered all of the equations and led to relativity. And then there was a quick run-through of the Tesla Colorado Springs and the Bolinas Alexanderson antenna and some more practical type of transmission structures like the Los Angeles Department of Water and Power transmission line and then transformer resonances. None of it was in any detail or allowed for any calculation. This time around, it's not going to be layman-orientated. It's going to be more engineering-orientated, and the mathematics is going to be fully developed with the emphasis on what's called the equivalent network of these devices, or what are known as analog computers, and the theory and the development of the concept of the analog computer, and then its application primarily to the Bolinas Alexanderson antenna, and then, if there's enough time, to the Colorado Springs. And there'll be numerous practical examples in the beginning that lead up to it, such as probably in mid-May. But then we have to lease a space from the whatever you want to call the group, the syndicate that has all the Sillyphone facilities, and then put the terminal equipment in the building. We have no money for that lease right now. We're barely able to pay for the building we got. So it's not really moving ahead very fast. But at any rate, last year, me going blind threw a monkey wrench in the situation. That has backed off. One eye is fairly useless, but one still works fairly well. Then when we began this year, the snowstorm started, and then the sewer system failed to the building, and the head gasket blew in the truck, so we got nowhere. And then everybody that provided money for the situation called us cat turds for not finishing by the end of the year, and it seems that they expected the whole Landers facility was going to be reconstructed, which is not realistic. So nothing is moving ahead very fast, but by the end of this year, both the east and the west transmission structures are expected to be finished. Now, the west one is more of a scientific type of structure where it's adaptable and that you can sectionalize it, and there's networks that can be attached, and there's test lines for measuring phase velocity and all the characteristics of the structure, where the west one is basically a simple structure just to start receiving without a lot of complexities and experiments, and just get the thing up and running with basically just two ground systems on either end of a long transmission line. That's the easiest way to start. And so that's what we're going to emphasize our effort on first, is to get something that's receiving and ready to be hooked to a terminal facility, in this case a large microwave site, so that when the money comes to lease a space in there and get a link, then the Earth signal receiver should be available through the internet, or however, what kind of broadcast mediums are available this day and age, where people can dial into the thing and listen to what's going on in the Earth in the Mojave Desert.
Well, that would be great.
Now, which one is east and which one is west? Which one is near your shop?
That is the west one.
Okay, that's the west one. So the east one is the one which is a couple hundred miles from there.
Yeah, it's about 250 miles away driving. So as the crow flies, it's probably maybe 180 or 200. So that's the optimum distance for stereo reception. Here we might have a problem with power line interference because the utility company, internationalist utility company that's taken over all the electrical lines in Nevada, seems hell-bent on creating a giant jamming device out of their electrical grid and is quite obstinate about it. So we're afraid that the structure here might only be useful for mathematical study purposes and will not be good for reception. So we can't really get these things out where we want them because of for one thing, to put up 40 or 50 utility poles is beyond anything we can afford or do between the two of us. So we have to use structures that are already available, that are provided by the Bureau of Land Management, usually abandoned telephone company or cable TV, or military facilities that we can reconfigure. But they're not necessarily in interference-free zones. We do have an easement near San Francisco where we can put some kind of structure up in a completely interference-free zone, but this is not a good transformation from magnetic to dielectric, so I was able to calculate the dielectric forces as well as the magnetic forces and show the relationship between the two, and then put the whole thing in a basic algebraic form that finally leads to a Heaviside equation for the forces themselves. And it allows you to actually calculate how much force is on the conductors in a transmission system during a short circuit or some kind of condition where there's a lot of current flow, and it's actually pushing the conductors hard enough to make them fly off the insulators or to make the windings fly apart inside a transformer. So then in Notebook 6, which is not out yet, all of this stuff is reduced to the level of the Lone Pine writings, which is basic algebra, and then the dense theory part is over, and then it goes back to a very practical situation of commonplace electrical power lines and actually calculating the fault current and the forces upon the wires and the voltage drop and energy lost and all those kind of things leading up to the generalized transmission concept, which will appear in Notebook number 8. And then Notebooks 9 and 10 will probably bring this into the actual calculation of Tesla transformers and Alexanderson antennas. We'll have to see how it goes. So, because I'm being very methodical about laying a groundwork for everything, and that takes about 100 pages for each basic idea. So this is probably going to be about a 1,500-page collection of notebooks.
Okay. We can probably see if anybody has any questions on Notebooks 4 and 5 that were recently released. Before we do that, are there any things that you want to cover first before we go into that?
Not really. Not yet, anyway.
Okay. Well, what we'll do is, if you're listening to this call right now, everybody is pretty much muted out. But if you have a question on these recent notebooks that were released, the Thompson and Steinmetz notebooks, which were available on powerofether.com, you can hit 5 and the asterisk, and that'll give me a little symbol next to your phone number, and I'll call out your last 4 digits of your phone number, and you can hit 4 asterisk, and that will unmute you, and then you can ask your question. So does anybody have any questions on those notebooks? Just hit 5 and the asterisk. It doesn't look like anybody has any questions. Okay, well, we can just open up for general questions if anybody has anything that they want to ask. I know in the Facebook group there's quite a few people saying that they wanted to have a Q&A call because there were so many different random questions. There was no way to address them, one at a time on there. So let's see. Okay, if your phone number is ending in 4394, I believe I just unmuted you. You can go ahead and introduce yourself and ask your question.
Hi, my name is Mel Messer, and I'm wondering how Eric is doing on his seismic sensitivities project.
Okay. Am I online, Aaron?
Yeah, you are. Did you hear the question?
Yeah, I came in clear.
Yeah. Oh, okay.
So everything's basically on standby right now because of weather and catastrophes. We haven't made much progress on the line, so we're planning on resuming the situation in April 1st. We have pretty much all the equipment. The complication is we don't have the money to build the terminal building for the seismic graphs and their amplifiers and modulators and what have you. That's a big hang-up. So it looks like the situation is going to rest in that we can have the telluric antenna structures complete. The one to the east of the test site, we expect to have operational an electric railway line and then a phone line running between two towns. And so familiarity can be gained, and the emphasis again will be showing that the velocity of light really is a numerical and dimensional coefficient. It really doesn't have a lot to do with the speed of transmission, or there might not even be a speed at all.
Okay. And so, okay, so that'll be the presentation at the conference. And then what is the title of the presentation going to be?
Oh, that's still being hashed out. I think I gave you a...
okay. Yeah, electrical
kind of
transmission. Yeah, electrical transmission in multiple coordinate systems.
Right.
Okay. And there is a description. It'll be one or two short paragraphs, which I'll be putting up on the conference website. And let's see. Now on notebooks 1 through 5, recently we released notebooks 4 and 5, which you refer to as the J.J. Thomson and Steinmetz notebooks. But there's also notebooks 1 through 3 that come before that. We decided to put out notebooks 4 and 5 first because after your presentation at last year's conference, The Power of Ether as Related to Music and Electricity, that ended with you going into some of these equations and straightening out some of the mathematical stuff that was in the back, that was in some of J.J. Thomson's work. And there was such a huge response with people being interested in more on J.J. Thomson that's kind of why we released these first. Do you want to give a little synopsis of what notebooks 4 and 5 are, the ones that we just released about 2 weeks ago?
Well, the whole series of notebooks, including the ones that I'm writing now, are based on the extraluminal presentation and the upcoming presentation. Notebook number 4 is the untangling and deciphering of the chapter on the Faraday tubes in J.J. Thomson's book, Recent Researches in Electricity and Magnetism. And I don't think anyone has ever untangled them before. And the emphasis was to show how resistance comes about inside of a metallic so-called inductor and define its dimensions so that in later notebooks it will be known exactly what resistance is. The notebook prior to that, notebook number 3, develops inductance and capacitance, and then notebooks 1 and 2 are basically the prior presentation verbatim, just written down for the more layman-orientated type of situation. Then notebook number 5 is a result of a paper I spent. Yeah.
Okay, it sounded like there was a little bit of interference on the line. Okay, it seems like it kind of cleared up now.
Okay.
Okay, go ahead.
Somebody's transmitting. So, yeah, notebook number 5 is based on a somewhat obscure paper by Steinmetz that allows you to accurately calculate the forces on the conductors in the transmission system from the magnetic standpoint and utilize it.
Eric?
Yeah.
Yes, it sounds like when you start talking that there's like some vibration noise that's coming over your phone that starts to get louder.
Well, it's not the phone. It's something in between.
Okay, that sounds okay right now.
Yeah.
Okay, go ahead. Sorry, I just wanted to kind of get this chance to...
Yeah, so basically, I've been struggling with trying to come up with these equations on the force of my own because the material that's in physics books is completely useless. And that's putting it mildly. So you can't get anything out of a physics book that will even allow you to perform the most rudimentary electrical calculations. This stuff is just pure garbage. So Steinmetz wrote this paper showing how the forces really come about, and then in his book, Impulses, Waves, and Discharges, he shows you how to make the time to open up a third avenue in this, or just get ourselves overextended. I would like to point out that that most of the external money that comes in, not really a lot of it goes directly in the project. Most of it has to go into supporting the building. And the public, what do you call it, the crowdfunding or whatever, that money, all of that pretty much went into buying the necessary hardware. And then we received a massive donation of equipment from a group that called themselves the Eric Dollard Fan Club that not only has allowed us to build the terminal equipment for the lines, but to set up a rather significant Navy electronics technician shop here in the building, but we don't have any money to put in the benches or the electricity or all that kind of stuff. And most of these kind of things, including, the gas for the antenna work, the food, the small parts and the expenses and car repairs, all of that comes out of my Social Security and one matching fund donor. So, as Josh Reynolds said when he cut off everybody that he'd been funding for quite some time, is that Eric Dollard has done more on welfare than you have with my millions.
So, do you have more questions about the seismic project?
I drank some water.
Okay.
Sir, did you have any more questions about the seismic project?
No, but thank you for asking. I'll contact you on Facebook.
Okay, thank you.
Yeah.
Hey, Eric, is there anything you might be able to mention about other applications of the transmission lines once everything is up and running besides seismic forecasting?
The main emphasis of the project is the continuation of what I was doing at RCA Bolinas, which is developing a ship-to-shore communication system.
Uh-huh.
So that's initially what RCA had set me on in 1974. And neither the district vice president nor myself knew anything about Tesla back then. I had discovered a lot of what Tesla was doing on my own in the laboratory that was provided to me, or the equipment was provided to me to build the laboratory in my parents' garage. So RCA was on its last legs, radio was becoming obsolete, and the satellites were taking over, so my job was to figure out some way to come up with a new ship-to-shore communication system to revitalize the business, but that took about 20 years to figure out. And then by the time I figured it out, they took the station license away and destroyed everything there. So, and then let Greenpeace have whatever remained. So now it's starting all over again.
Okay. Let's see. If your phone number ends in 9151, I'm going to unmute you right now. If you want to go ahead and introduce yourself and ask your questions. If your number ends in 9151, you should be unmuted if you want to go ahead and ask your question. Let's see, if you have your phone muted, shouldn't be muted, but in case it is, you can try 4*. Okay, it looks like you're unmuted to me if you want to go ahead and ask your question.
Hello, can you hear me?
Yeah.
Sorry, had a little trouble with the phone. Eric, I've been watching with great interest lectures that are available on YouTube recently. I have a friend that has built all kinds of free energy devices and inventions. His whole house is a lab, basically. We've been just very interested in what you've been doing, but I am a little bit new to it. So